Hi, so I'm Jeff Baumes from Kitware. I have a varied experience. I started with my PhD in graph theory and then ended up at Kitware doing information visualization. So if you haven't heard of Kitware, we collaborate with actually several people in this room and on the phone, so a lot of you may be aware, but we're doing collaborative R&D in an open source environment. So we team with academics, government, and other industry partners to do all sorts of advanced solutions for software solutions that we use our well-known open source toolkits to somehow make money. That's the most common question I get. How do you possibly make money? Not every line of code we do is open source, but a lot of it is, and it's the really partnerships that we make, teaming arrangements, working with people. We do a lot of government work where people in government are seeing the benefit and utility of having open source communities as opposed to a 3-year-long program where the software dies at the end. So like I said, we do software. We do lots of little things and big things. Our biggest, I guess, claim to fame is the CMake toolkit, where it's cross-platform building, so across different systems, and then integrating that with software dashboards for continuous integration. And these are distributed, much like the GitHub type mentality where everybody can contribute. There's not really a central thing running of all of our tests. If you have a special system you want to test, you can deliver your results there. So we do a lot of software type stuff, and we focus, that's kind of our specialty, is getting research code into a quality software process mode. So what do I do and what am I passionate about? Rapid visualization design. So the DARPA XData program is enabling a large number of very talented people to work on this problem in an open source way, to give tools to people that wouldn't have those tools otherwise, to do analyses and visualization. There's kind of the two components of that coin on the XData program. And what we're doing specifically is there's a tool called Tangelo that we're trying to put everything that we can think of together into a system that would allow for rapid analytic, visual analytic application development. So trying to eliminate as many barriers as possible in the web application domain. So somebody that does not write web servers is able to put together a simple Python script and put together a web server with 10 lines of Python code, making some of the intractable tools like D3 accessible to people by wrapping some of those things up. And we've just iterated over many different data sets and many kinds of visualizations to flesh this out over the course of the XData program. Another area that I'm working on is infectious disease. So this is very much a multi-dimensional problem. Where are diseases, where are outbreaks happening, and working on tools for visually representing that, and doing some work in partial constraints for multi-dimensional data so that you can see where things are related in space, but then kind of start grouping them in other dimensions as well to see how the dimensions interplay with each other. So visualization challenges. Really what is coming out in my experience with visualization is that there is supposed to be this rich symbiosis between analytics and visualization, and it's just not there. And it goes into the next point where the web in particular is an open source, and all these types of trends in software are crashing things together. So you could do pretty much whatever you would want to do. You could mash up a Google map with a streaming scientific data visualization if you wanted to, right? There are tools to do this kind of thing, and part of it is to build the tool set up to make all sorts of things possible. But what happens when they all crash together? Because people are doing this. Journalists, and researchers and just common people that just want to learn something or figure something out are trying to put all this stuff together. But can it crash in some good way where lots of just bad and horrible things don't happen? And that's what I'd like to try to solve. How do we get the research solutions from the research code that will end with a project integrated into a robust, bigger system that's open source and maintainable over time by a community of people? And then the last point, which I think several people are making, is that the big of big data is not really the problem often. At least you know what to do if it's organized. But if it's messy, then you're stuck. And if it's big and messy, then you're kind of double stuck. And a wish list I want to point out is, what if in this mashup environment, you have a interface that can inject expertise both in data science and visualization into components that people can actually use. And there are tools that can start to let you do that. You can embed code editors into a browser, for example. You can, Stanford came up with this Lyra Viz editor. There's Vega visualization specification and lots of other easy-to-use tools that are coming out of places like Harvard and Georgia Tech, and tools like BTK Web that allow you to do stuff, scientific visualization robustly through the internet. And can we piece that all together? We're starting to try.